what is passive house?
If you build the home and you design the home appropriately, it'll be comfortable to live in passively, meaning reducing the need for mechanical intervention. 3 rules of construction: gravity never quits, roofs always leak, and mechanical equipment always breaks. The cost of energy in the South is lower than the North.
I'm excited about this episode today.
This is going to be awesome.
This is going to be awesome. So our guest today, Nicholas Fair, welcome. Thank you for coming.
Appreciate it.
Come on.
With Consulting Engineering Services. So a few episodes back, we had Vish on, who's with the your San Antonio division, but you're out of Massachusetts.
Correct.
And I find it, I'm extremely honored that you would make the trip down here to come talk to us yahoos, down here in Texas. But we're going to get into some really, really fun stuff today. So what we're going to talk about is passive house, right? You hear this term thrown around a lot: passive house certification, passive house design, construction. What is it? So that's what we're going to talk about. What is passive house? And we're also going to get into some pros and cons of passive house. And then, what are some reasons you might consider building a passive house certified project? So it could be residential, it could be commercial. There's a lot of different, it's not just a residential thing, even though it is passive house, that it can be applied to a bunch of different projects. So, Nicholas, you are certified passive house designer or engineer.
Yep.
So I'm really excited to get your thoughts on this and take a deep dive into it. So it's going to be really educational. But before we dive into that, Michael, you got some really fun stuff for us today. I don't know what you got.
I do have some fun stuff for today. Our headline for the day is the NAHB came out with a report in March for a special study for housing economics, and it focused on young adults. So it was a survey of 18 to 25-year-olds across the country, gender, race, just all across the board. And I found a couple of things that I just wanted to highlight. I actually printed out and was going to point out a couple of things. One of the things is that when they asked these young adults what career field they were interested in, construction was doubled in response to the same survey 10 years ago.
Wow, that's good news.
So I thought that was pretty cool.
Good job, Mike Rowe.
Yeah, that's true. Absolutely.
Am I allowed to do that?
Heck yeah. Mike Rowe has been a huge voice in the trades and the construction industry. Yeah, 100%. I mean, Mike Rowe's, he's out there, doing God's work. So.
I thought that was super interesting. And another interesting thing was they broke it out in a couple different demographics, like male and female. Young adults who want a career in the construction trades. Male was obviously higher, and rural was higher than urban or suburban.
Yeah,
seemed pretty self-explanatory.
Yeah.
And then this was interesting across the regions of America. The highest was the West Coast, which I thought was interesting.
That is interesting.
Northeast, Midwest, and South were all similar percentages, but in the western region of the states was almost double.
Yeah,
which I thought that was pretty interesting as well.
I mean, that's seems positive. I mean, they keep talking about the shortage of labor, right, and and skilled labor in the trades. So I mean, that seems like that's a positive development. I mean, the interest is there, right? Now we got to get the competency part
100%,
of that.
100%. Yeah. Well, the median age of someone in this industry is 42. You know, you think about that, and that's increasing.
Yeah.
So from 5 years ago, that was younger, and so we do have a problem on our hands, and it's great to see that these younger adults are interested in getting into this industry.
There's a lot of opportunity out there. It really is.
Here's what's crazy about that median age, though. When someone starts in the trades, they're generally starting straight out of high school.
Yeah.
So they're starting 4 years younger than the office and type of employee, which means that the other end, in order to hold that median at 42, it's got to be 4 years older to have the same median.
100%. Yeah.
Which just means like, hey, there's a lot of
there's some people
retiring
working
skill sets
who are
out
some
there
old guys
that
who
need
are,
to get replaced.
Yeah. One thing that I thought was a negative in this report was that there was they asked a question in the survey of what reason you wouldn't consider a career in the construction trades, and 45% said they want a less physically demanding job.
I got some bad news for you.
Like,
I got some bad
construction
news.
is physically demanding. Now that said, I think there's a lot of I don't know. I mean, it's a growing industry, and there's a lot of different ways to get into it. I mean,
That's true.
Take our jobs for example. We're in not necessarily a physically demanding part of the industry, but still involved in it.
Yeah. No, that's a good point. I mean, there are, a lot of positions that are, like you said, they're not physically demanding. I mean, mine included. It's more of a managerial type role.
Mm-hmm.
Now you do have to, roll your sleeves up and get your hands dirty from time to time,
Can't be afraid,
and scuff some people up. But other than that, it's pretty easy. It's more mentally demanding, I think, than anything else. Which sometimes I feel like can be worse. Like I would rather. It's like not have the mental demand and load. It's like, man,
and just go
digging ditches is easy. Just give me a task to do. I'll knock it out. Like that's easy.
Yeah.
But that to your point, that's true. There are some positions, and who knows? Now they're trying to get robots involved, which I think the last episode we talked about that, and AI and robotics, and It's not really coming for skilled labor anytime soon. It's really not. There's just no way to replace,
the field,
field experience and hands-on learning and the heart and soul that you get, with a labor or a human being than a machine. So, tons of opportunity. Starting your own company, again, may not be as much physically demanding as it is mentally and emotionally. I mean, all about that too, starting your own company. So, there's a lot of different avenues you can go down and pursue. So, but I think overall that's good news. That's a good report.
I think so too.
Yeah. Fantastic.
Excited about it.
Thanks for sharing. Nick, good to have you on.
Thank you.
Let's dive into this. So, again, thank you for joining us here in Austin, making the trip down here. CES, man, that's a big company, isn't it? It's like nationwide, right?
So we are nationwide. Yeah, we are now 8 locations across the country.
Wow.
And I'll say when I moved from our original office of Connecticut to our office in Massachusetts, which is now 12 years ago, that was only our second office.
Wow.
And then grown quite a bit from there. And every place we grew was because somebody at CES, life took them somewhere.
Mm-hmm.
Yeah. They didn't want to leave. We went with them. I mean, the reason why I'm actually sitting here is because Vish, who you interviewed before, I hired him in my office in Massachusetts, but had the opportunity to be down here closer to his family.
Yeah.
His wife was from here.
Mm-hmm.
And so that's why my connections to the Texas area is because when he came down here, I was helping him to get this office to where it is now.
That's awesome.
And now if I get to come down here, it's because he invites me.
Yeah.
Or somebody else invites me.
100%.
Not because I'm demanding to come down. So it's great. And that's how we've done it across the country. So we've got some offices that have, less than a dozen people.
Yeah.
Some, like our office in Connecticut has the most. Some have a dozen, some have 20, right?
Yeah.
So it's as each office grows naturally based on the next generation behind.
Yeah.
Tell us a little bit about your expertise and career path, finding yourself into this niche.
Sure. So when I started at CES, I was wrapping up college. Started out as an intern in the office in Connecticut.
Yeah.
And I was put on a team where we did all luxury residential homes and apartments. Did a lot of work in New York City, out in Long Island, Connecticut. And so that was my foray into it. My degree is in electrical engineering.
Awesome.
That's what I came out of school with.
Yeah.
Cool.
And we started getting into, as a company, the sustainability, but mainly around the building envelope, because we had learned a lot of very talented architects, beautiful, beautiful buildings weren't super strong in the building envelope world.
Yeah.
And the problem would be is we'd get dragged into an issue and say, well, the mechanical system doesn't work. And on a couple of jobs, we realized, well, hang on, something was specified, but the architect wasn't quite sure how to make sure it got done correctly, and it didn't get done correctly.
Sure.
And that's when we realized, well, the envelope is actually part of the mechanical system in a way. It's one big system, right? The better the building's
It's all
built,
working. The pieces are all working together.
the less things there need to be.
Yeah.
So that's how we got into it. And then a bunch of us became HERS raters. So, which I also am, which was in the States before Passive House was.
Right.
And that was the original, I'll say, benchmark for low energy homes. And we started doing it because, well, we're already doing all the load calcs. We're doing all the engineering. Well, we can do the service as well. It's all part of it, right? So we started becoming HERS raters in the company. And then I'll say Passive House, kudos to them. They've really grown quite a bit in their awareness. They're in a lot of codes now. And so we were seeing the same thing where, okay, well, the Passive House certification means something. We already know this. We know it from the ResNet, the HERS as engineers. So now we need to add this. So I wear multiple hats depending on where the project is and what it's being, whether it's going a HERS route, ERI route, which is the energy rating index, or whether it's going down the Passive House route, which has its own set of standards.
Yeah. Yeah. And that's a great segue into really our first topic, which is what is Passive House? Because this is something that, it's not widely adopted here in the South. I think there are a couple of case studies, a couple of projects that have been done around the state, but it's not widely adopted here. And I think, a little history behind it. It started in Europe, right? Or like Germany.
Correct.
Or
And I pronounce Passive House.
House.
HAUS is how they spell it there. And that was the European standard forever.
Right.
They don't have the HERS or the ResNet because that program was actually done with the assistance of the U.S. government with the mortgage industry.
Oh, really?
To try to get older homes to be refinanced or purchased with more cost than the house was worth, but with the idea that it's been proven to the mortgage companies that if they put an extra $100,000 onto a mortgage and that went into some sort of upgrade of the home, the extra mortgage cost would be offset by the savings of energy that they're paying in their utility bill. Oh, cool. That was the foundation of where that came from, to try to reuse housing stock.
That's awesome.
Interesting.
Now, it doesn't get used to that very much, but that's what it was. That was the original intention.
That's super cool. And as we've talked about before, remodeling, using old stock is valuable. We have a ton of it here in the States, and that's a much more affordable way to convert over new units than scraping them and building new. Yeah. So that makes sense.
Right.
Yeah, and I like it from a longevity perspective. You're building to a much higher standard, than just meeting code. And so, if your goal is, to build high quality in a sustainable way, well, a way to do that is just build for longevity. Build it to where it's not going to be remodeled in 15 to 20 years. Like, it's going to last much longer than that. So I definitely like it from that perspective. But let's go back a little bit, and I want to make sure we clearly define, for people listening, what is Passive House? It's a building standard, right? It's a way to apply some high performance building techniques to either a residence or a commercial building, or some kind of multi-use building that's going to meet these high performance standards.
Correct.
Right?
And let's look at what the name is. The name is actually great for what it is. Passive House.
Yeah.
The idea is if you build the home and you design the home appropriately, it'll be comfortable to live in passively, meaning reducing the need for mechanical intervention. The original Passive House would have been the longhouse done by the Native Americans, or the teepee in the plains, right? Those are original passive houses, right? And it's actually really kind of cool if you're into this type of design. doing some research into early American architecture is really cool. Because you can see those houses had to get built to be passive house as best as possible. So houses that were built down south were built to naturally stay cool without air conditioning. They didn't have it.
Right.
Yeah, I was going to say, could you consider any home built before the invention of AC to be a passive house?
Arguably.
Yeah.
Yeah.
I mean, yeah.
Is that?
Yeah, I mean, components of, for example, dog trot houses, right, where you've got this long hallway in between two. That's
Like a shotgun house?
in the south. Yeah, well, no, not a shotgun house. A shotgun house is like just one long, just rooms all coupled together. But if you take two of those, put them next to each other, you'd have a dog trot house. In the southeast, that's super common.
Yeah.
And that is an example of something that hallway naturally pulls breezes through it.
Breezes, right.
So that's an example.
And very common, like really cool. Take a tour through like Charleston. You see the old homes where they have, these very, very long, narrow buildings, and they had this open space next to it. When you look at it, you don't realize it's like a fake facade, almost like in the overhang you might do for a building aesthetically. But the idea was it allowed this natural cross breeze, gave you more living space outdoors. The first house I ever owned when I bought was built in 1736.
Wow.
And it was that style. It was in Connecticut.
No way.
And I was talking to an architect I knew who was in New Haven, right near Yale. And I said, this is kind of weird. This matches a house down south, except, I'm like, but we don't have that climate.
We're in the Northeast. Yeah, what's
right.
up?
And he goes, yeah, but you still have humid summers. And you could, the fireplace was dead center of the house.
Right.
Center mass chimney. So you had the east to west breeze.
Yeah.
Minimal northern exposure.
Yeah.
And because that was the cold side, right?
Yeah, right.
And you could always burn more wood, right? It was New England.
Yeah.
In the 1700s, burning wood was not the limitation.
Plenty of wood.
So it's like, and so you start to see how that. So again, going back to what passive house is the idea is you're building the building as efficiently as possible to not need any intervention. So a purist would say a passive house shouldn't have any air conditioning whatsoever.
That's not going to fly down here in the South, I can tell you that.
It's not going to fly a lot of places. And
a lot of places.
Here's why.
Yeah.
When you build the building that tight, sure, you can keep the heat out better in the summer and keep the heat in better in the winter, but you still got the human element. The human element today still is going to turn on the TVs. They're still going to be using all sorts of stuff for cooking. They're going to be taking showers.
Totally.
And so there's still internal gain and there's still a lot of moisture buildup. So the number one thing that's important with recognizing passive house is how do you deal with humidity? And so that's why even a true passive house is never truly passive because as you make it tighter, that moisture inside has a hard time getting out. So you still have to address that.
Yeah.
It's really interesting.
Yeah. So now you're kind of introducing more mechanical systems in the design to be able to deal with that, right? Like you might have a reduced heating or cooling load, so maybe you can afford to utilize a smaller, tonnage, right? A smaller system to handle that. But being that it's smaller, is it going to be able to cycle on and off enough to be able to remove the moisture that's in the air, right? So you have to have a separate system to deal with that, correct?
Correct. And so when you look at heating a building, it's pretty straightforward. You use more BTUs, whether it's more electric heat from an incandescent light bulb, right? That actually gives off a lot of heat, or a heat pump, or whatever you're using, right? You're just adding heat. When we're talking about the cooling side, there's two types of cooling that's taking place. There is dry heat and wet heat that has to be removed. The dry is what hits it when the sun hits the building, the outdoor temperature, it warms up. The wet is the moisture element. And that's the piece you're getting at when you're talking about the system cycling, that if you're hitting the dry temperature fast enough and the AC turns off, because that's what it sees as on a thermostat, then you stopped dehumidifying. And most equipment has been designed and built around the reasonable ratio between the wet and the dry heat that's been normal for building construction forever. That ratio changes when you're building to a passive house standard. And the problem is the off-the-shelf equipment isn't set up for that ratio.
Interesting.
So you have to add things depending on what you're using. Maybe you're adding dehumidifiers. You are using something that might be a little bit more complicated that has what's referred to as a reheat. So you can do overcooling, extra dehumidification, and then reheat it to not overcool the building. Something, if you're talking to a commercial engineer, commercial architect, they know what that is in a heartbeat. They all know what hot gas reheat is or a reheat coil. Those are very standard commercial terms, extremely rare in the residential setting historically.
Yeah.
Now it's starting to become more common because of this phenomena that we created of not having the AC run long enough, hard enough to really pull that moisture out.
Yeah.
Okay, so question on that. When you say that, okay, there's been sort of the standard between these two, right? The dry and the cold. I mean, the dry and the wet. Now, with a passive standard house, that's changing. Tell me a little about why that's changing.
Sure. So it's because when you look at the load of a building, let's use a commercial building first.
Yeah.
When you look at a commercial building, the envelope many times has less to do with the load of the building than the people. A lot of high population, peak of the day, very predictable, a lot of electronics being used, and a lot of ventilation air needed for those people. And that drives most of it, which brings a lot of moisture at the same time as bringing in temperature.
Interesting.
In a house, the structure per square foot, the envelope historically has been the bigger load compared to the people. So that's what we learned all of our rules. Yes, we did our calculation, but all the rules of thumb you've heard of over the years got tied to that, right? And so the amount of ratio of moisture to temperature through the envelope, which is the biggest factor, is very predictable. Yes, climate change is happening. Yes, places are getting warmer, but we can still see the slow trend of that, and we can still look at it many, many years back and understand that ratio. When it comes now to the tighter envelope, the amount of load that the envelope puts on the overall building is coming down compared to the internal gain. And so that's where that ratio starts to get a little messed up. The moisture part, the percentage of it, while the amount hasn't gone up, the dry point has come down. So now the ratio of it has come up. And that's what we're now trying to contend with and the challenges associated with doing it correctly.
Yeah.
One thing that I often find in working with clients is that there's a perception that houses haven't changed over the years. If the house 20 years ago is basically the same as a house today. And I think what you're saying is really interesting about, well, actually, it's a slow process, but houses are changing. The way people are using them is changing. There's much more, complex systems. Something and the construction and assembly of a house, for example, a tighter envelope, that's something that 20 years ago, and it was different than this today. And this is one of the effects of that we're seeing is in the mechanical systems. I think that's so fascinating.
Yeah, and agree. And I mean, you're seeing changes in the design as well. I think we talked with Wynn about some of the designing for multi-generational use, right? And I think we're going to start seeing more of that. Whether, I don't know what your opinion on that is, whether that's good or bad, but, you see a change in how homes are utilized, like you said, and the design over the years. But real quick, I wanted to show some key principles of passive house design. Like, what does that actually mean? And this is just straight off of Google, but I think this is a good, summary of like what you might find in a passive house design. Things like having continuous insulation, right, on your building envelope, and maybe even thicker insulation, higher R values, really extreme airtightness. And that includes, high performance windows, right? You're going to get a little bit higher U rating on your windows or doors, maybe a better seal to try to get that air tightness. And then, we've already kind of touched on the ventilation and heating of the home. There's some different systems that you might need with a passive house design, and then trying to utilize, for heating purposes, trying to use like solar heat gain, to help, heat your home. So those are I just wanted to kind of sum up like, hey, these are some of the principles or qualities that you might see in a passive house design. So I kind of wanted to use that to get into maybe, what are some pros and cons, right?
Sure.
And I think the first thing that pops into people's head is, how much is this going to cost, right? There is an initial upfront cost with doing a passive house. And I don't know if you can speak to that at all. Just through my research of it, it can vary, obviously, depending on climate and, size and scale of the project. But it's, what I read is that it's typically about a 30 to 35% increase in the overall budget to go to utilize this passive house design. Is that?
Yeah, and it's certainly going to change by locale.
Right.
Based on one is just the overall standard of cost of construction of where you are.
Yep.
The demand on the building from the environmental factors. So let's just say everyone's heard the term net zero, and a true
I'm glad you brought that up.
A true net zero building, in my opinion, a net zero building generates the power on the structure that it serves.
Yes.
Now, that definition has been modified quite a bit to be, okay, you could do a ground mount and that counts. Okay, that's in my mind, that's a net zero site. And some jurisdictions had said, okay, well, if you're buying green power somewhere, you can still be net zero. It's like, okay, well, that's
kind of a stretch. But
it's a little bit of a stretch, but it's getting to the end result, because sometimes based on the building, you just might not be able to do it if it's a taller vertical building. Maybe you're talking about housing, right? Where you've got a lot of units compared to service area. So to do it as a development, there's reasons to play that out. But fundamentally, what we want to get to is, if you're going to say the term net zero for a moment, net zero down south is easier to do than net zero up north.
Oh, interesting.
Why? Because the overall delta T, interior to exterior temperature of a building over the course of the year, is much more aggressive when you're dealing with 0 degree winters on a 70 degree building versus 100 degree and a 70 degree, right? It's a 30 degree delta T versus a 70 degree delta T. A lot more pressure difference on that wall. So 100%. It is more difficult in that way.
Yeah, that's fascinating.
At the same time, though, what's kind of funny is when you look at, I'll say I'm going to use this HERS example for a moment, and we'll go back to the passive house. When you look at the way a HERS model is done, you are making the building twice inside of the modeling program. One is based on the, I'm going to screw this up, I'm sorry, the 06 energy code. I believe that's when it first came out. And then one is against whatever you're building it to today.
Interesting.
You get a better HERS score for improvements on an envelope for a building way north than you do way south. Why? Because the variability that it's picking up is showing a greater reduction, because you're comparing it. How much % better are you doing per the code or the old code baseline?
Oh, I see.
So it's one of those things where it's funny how statistics and math can help you one way or the other.
Yeah.
It's also the reason why a much larger home for the same number of people will do better on a HERS score when you make it more environmentally do better envelope than a smaller building, because the envelope element is a bigger piece. But the lighting, the appliances for a 4-person family is very similar.
Yeah.
So it's one of those goofy phenomena that happen out of the math. The math is the math.
Yeah.
But this all kind of correlates back to the passive house. Where is really what we're looking for is, what is the return on the investment, right? Or where are the diminishing returns? And that is a reality. And like every program, there are some downsides.
Sure.
I'll say one of the biggest downsides I have with the passive house program that an energy model does differently is it doesn't handle different locations variably different as well as it could. And I know that they're always looking a way to improve that.
Totally.
It's not a one size fits all thing.
Right. You have to look at that, because sometimes you're looking and saying, man, to hit this, whatever this benchmark is, I can see I've gone past the diminishing returns. And for the client who's paying the bill, the project that's in Boston, Massachusetts, versus, let's just say, Knoxville, Tennessee,
Yeah.
where they had some of the lowest power usage and very clean with a lot of the hydro they have out in Tennessee Valley Authority.
Yeah.
The variable changes. So wait a minute. If we truly want to look at this from an environmental standpoint, if I'm getting power from Tennessee Valley Authority, which is hydro, is it really worth going past Faust if I'm going to use this much more of a product that required fossil fuels to make it? It's kind of funny. Do I really care about past Faust?
My energy I'm already getting is pretty clean.
Right.
So
it's hydro. It's a little weird at times, which is also generally why when you look at where Passive House is getting the most attention, it is usually tied to areas that are, I'll say, research hubs, because you got a lot of energy associated with it, right? You could use Massachusetts as an example. So much research going on right now on environmental stuff in Massachusetts.
Sure.
So you got a lot of energy of people who are helping write that legislation, doing the research.
Yeah.
But also then you got to tie it to places where utility costs are high. Let's use California, right? California has really difficult elements when it comes to their power grid. So the people who are there, they're going to see that benefit much faster than the person who pays very little in power.
Yeah.
Right.
So there's more energy behind it.
Yeah.
Sure.
That's so interesting.
Yeah. And so I don't want to harp on like the cons too much, but you know, I think I said earlier, you know, one of the pros about Passive House is really you're getting a you're getting a more robust system, right? A more robust envelope,
Robust building,
right? And so with that, right, that's a big pro, but a con maybe to that is there might be some design limitations, right? So you might not be able to do some really complicated architecture. You might have to keep things simple, right? No large expanses of glass, right? Which might be pretty popular in some regions. If you want to capture a view, and you don't want walls and things in the way. Yeah. You might be limited there on some of the design aspects there. So it's kind of weighing the design with the overall the performance of the house. Yeah. So
and then what you mentioned, Nick, about diminishing returns, looking at investment, something that has a specific standard like Passive House, for example, or Net Zero, Living Futures, LEED. The list goes on. Well, at some point, if there's a region-specific site that a project's being built at, there might be a point where there's diminishing returns before you can get to whatever that specific standard is. So it's very, very site specific as well.
Yeah,
definitely. And as an interesting one, one of the things that we can't forget. So say you're doing a new school, right? Commercial building, probably going to face the main road. However, if from an energy standpoint, if it makes more sense to turn that building slightly or even 90 degrees, you can play with that from how you do the civil work for the parking lot, the buses, the playground, the ball fields, right? You can use those elements to help you.
Yeah.
If someone bought a piece of property on the south side of a lake and the view is to the north, well, they're going to want their big glass on the north, 100%. Regardless of what the energy says it needs to be, 100%. Because as realtors always say, location, 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 right?
Yeah. Yep.
So you have to use the elements as best you can.
Yeah.
And sometimes that does hurt. Something that we actually up north that we talk a lot with, and landscape architects have starting to get into the Passive House game more with the understanding of, are you going to do deciduous or coniferous trees? Deciduous trees are terrific on the south side because in the summer they shade the building, which is what you want, but those leaves drop in the winter. Now you get that warm sun on it. Yeah. You put the coniferous trees on the north side as your windbreak that are always there to help protect the house. And so now actually the landscape element starts to matter. Yeah, because shading is a big piece. I mean, is a big piece. Down here in Texas, right? How many? Yeah. Oh, yeah. We do more overhang outside the building than what the conditioned space is sometimes, right? Yeah. And it's just the way it is. That's the lifestyle, but that's that element there.
Yeah, for
that's
sure.
Really interesting.
Yeah. Well, so I had a question. I just lost it. But well, okay. So I want to hear your thoughts on like why you think it is that it's not as popular in the South as it is maybe up north. This passive house, like why?
You mentioned kind of the research hub thing. Yeah, let's
Yeah,
go back
and
to
I
that
think
a little bit.
there's also diminishing returns part. One is, the cost of energy in the South is lower than the North. So the incentive to do it down here tends to be more emotionally driven than financially driven.
What do you mean?
Somebody saying, listen, I'm willing to go beyond diminishing returns of what I'm doing because I'm doing it for the right reasons. I want to be more environmentally friendly. The person who buys the Prius versus the Tesla. Almost, I'm willing to bet if you told everybody who drove a Prius right now, hey, I'll give you a Tesla the exact same price you bought your Prius for, unless they get range anxiety.
Yeah.
They would take the Tesla, right?
Right.
But they've done a cost ratio of what makes the most sense to them.
Yeah.
They know they don't want the Hummer.
Right.
The Tesla might be out of the price range, but the Prius falls right into a good sweet spot for them.
Yeah.
Yeah.
Similar element here is I think that's one thing that's going to hold back areas that have low cost is the people who are doing it and they're only looking at the financial side. Sometimes it's a hard sell.
Sure.
And that's where the building codes actually help, right? If cost was immaterial, then we wouldn't really do much. It would be very hard to get a lot of progress, right? Sometimes it's a weird mental state to have in the construction industry. The idea when you see right now, we're seeing gas prices go up, right?
Yep.
Everyone's freaking out about that for a lot of good reasons.
Sure.
Selfishly, though, at the same time, I'm like, do you know what that's going to do? People are going to want to build more efficient homes. People are going to want a more efficient car.
Yeah.
When gas prices go up, it actually helps the energy for doing more environmentally friendly designs.
Oh, that's interesting.
Because they're feeling the benefit faster.
Yeah.
So it's kind of a double-edged sword there.
That's
There's a little bit of a element.
So I've got a question for you in that. There's a variety of different kind of schools of thought, programs out there related to sustainability. Passive house being one. That's kind of the one that we're focusing on today. When you have a project that comes across your desk, how do you, sort through what's best? How do you help direct people? Hey, this is the best fit for you, because they might say, hey, Nick, we really want a net zero house, or hey, Nick, we really want a passive house, going back to that emotional pull. But you have a much broader understanding of the landscape. How do you thread that needle?
So I'm going to steal the famous Simon Sinek. Ask him why.
Yeah,
it always goes down to the why. Because I think a moment ago you mentioned the generational element, right?
Yeah.
Somebody might be doing it only because they want to save money. Somebody might want to do it because it's truly an environmental thing, or they might want to do it because they're building this home to be handed down to the future. And one of the biggest pros of doing something like passive house is you're very likely, building a building that's going to last longer.
Yeah.
So you're putting less headache on the second generation behind you, right?
Yeah.
It's kind of like you tell your parents, hey, listen, before you're really much older, can you please get your affairs in order? Because it's going to fall back on the siblings, right?
Let's iron this thing out.
Exactly. So there's a big piece of that. When you build to that level of passive house, the building naturally is going to survive longer. And people see me I give a lot of talks, a lot of AIA talks all over the country.
Yep.
And I always talk about my 3 rules of construction. Gravity never quits. Roofs always leak. And mechanical equipment always breaks.
Yeah.
And as an engineer,
Yeah.
the last one really hurts me, but it's true.
Yeah.
And when you build a better wall assembly, a better roof assembly, those systems are always going to, assuming they're built correctly, big caveat for anything, they are always going to outlast the mechanical system that has moving parts.
Yeah.
And there's a big environmental savings right there, right?
Yeah.
Less service calls, easier service calls, less complicated parts. So I think that's probably the biggest pro that doesn't get talked about enough is that you're putting your construction dollars into the most resilient element outside of the foundation
Yeah.
of that building for generational value.
I want to speak to that a little because I do agree that like building the passive house is like you are getting a really durable product, but it seems like it's only durable as long as you have power, right? Because you're heavily relying on mechanical systems to make this whole thing work.
Which is actually one of those funny elements about that. You're correct. Is that ironically a true, really well built passive house home can get uncomfortable in some ways faster than a non-passive house can. And it's because of the humidity element. Going back to that, you are definitely, you need to make sure that moisture gets out.
Yeah.
Because when the building, I'll say, breathes more. Now, in the dead of winter, breathing more is certainly not going to help you.
Yeah,
because it's going to get cold faster, right? But moisture wreaks havoc on buildings. It wreaks havoc on a lot of things. Yeah. And in fact, all the engineers, a lot of the guys I talk to, when you get a client complaint later on, and they say, "Oh, the client's mad. You know, the temperature's not the exact temperature." I said, "Well, the issue is humidity." Like, what do you mean? I said, "They never would have looked at the thermostat. No one can sit there and say, "Oh, you know, I set it to 70 and it's 72 in here." No, nobody can do that. We don't have that ability. What they felt was the space had a higher humidity level for whatever temperature it's at, the relative humidity, and their body couldn't cool itself.
Yeah.
Then they went to the thermostat. You could be off by 3-4 degrees all the time. If the building is dry and comfortable, they're not going to go look. It's kind of like the crazy people that live in Scottsdale, Arizona. Sorry, guys, if you do. They'll say they can survive a 110 degree summer because it's dry.
Yeah, that's
Up
true.
in Massachusetts, it hits 85 degrees. We're complaining.
Yeah.
We want to go there
Yeah.
because it's the humidity element.
Yeah.
And that is when that power outage scenario, again, it goes back to the humidity. And so that's where that comes into play. So it can sometimes become, now you start talking about, hey, I really should have a generator for different reasons. But I will say that's not usually that big of a deal to say why you shouldn't do it. It's just a factor. You just have to look at it. You should not do it because of that. You just have to recognize, what are we going to do? How are we going to address this?
Yeah.
It's actually kind of like for a lot of clients now who want to also go all electric and do electric heat pumps. We had the conversation, particularly in the northern climate. Okay, what happens when you lose power?
Right. Yeah.
You are likely going to get a bigger generator. And so we've done a lot of projects that are passive house. In your mind, passive house means no electric or no fossil fuels. But we're doing a project right now, passive house, where we do have fossil fuels. We do have a boiler because we did the analysis with the client.
Yeah.
And by looking at what was needed, their primary heating system is an electric heat pump. Yeah. They couldn't do geothermal very close to water. It was going to have a lot of aquifer effects in the site. So they're doing electric heat pumps. It happens to be in New Hampshire. It gets very cold in New Hampshire. They get a lot of snowstorms, ice storms. When we looked at the generator size that was needed to run those heat pumps during a very cold ice storm, it was massive.
Wow.
And he goes, well, I don't want all that on there anyways. I don't want my AC on. It's like, well, you got it. So that's how it works.
Yeah.
We did the analysis. We gave them a small wall mount boiler that was tied into their base heating system that allowed them to use a very small generator.
Yeah.
And what we said to them is, listen, your base building system is a passive house designed house with air source heat pumps, all electric. When you lose power, your backup system that keeps your house warm and lights on is a mix of those two elements. So your boiler is not a boiler for primary heating.
Wow.
It is your heating generator, just like your big generator outside is your power generator.
Right.
And when we ran that analysis, it made a lot of sense.
That's cool.
Yeah.
In fact, boilers are a lot more efficient than a generator.
Yeah.
Interesting.
So from an environmental standpoint, getting away with a smaller generator and a boiler is actually more efficient.
More
So-
sustainable.
But it's a conversation you have to have with a client, right? You have to kind of walk them through because it still feels weird.
Right.
Yeah.
No, I think that's the perception is a big piece of that. Again, going back to the emotional side, people say passive house. You know, even I think that. I think that, no systems or low, or low tech systems, and that's really actually not necessarily the case.
Yeah. Which it seems to me, I don't know. My biggest question really is passive house really worth it in our environment? And, in Texas specifically, it seems easier, right, to passively heat a home than it is to passively cool a home. Right. So here in Texas, you might be able to have this super tight, well-insulated box that on the inside, it's going to stay, a relatively, same temperature no matter what's going on outside. But is it comfortable? Is it what we're wanting? And, I don't know of a way to passively cool a house that's effective versus, if it's up north where it's cold, you can utilize solar heat gain, right? If it's super energy efficient, you just use the heat from the sun to warm the house. I don't know. I want to hear your thoughts on.
Yeah, I mean, so
that's my question is like, is it worth it down here in this environment?
So, I think it definitely is worth it.
Okay.
But again, it's a point of how far do you go down the path?
Mm-hmm. Mm-hmm.
Because, many houses in Texas are very comfortable without a great envelope by having some windows open and having a lot of ceiling mounted fans, right? You get some nice breeze going through there and it feels great. As long as you're out of the sun, that breeze really helps you out.
We
and
do
that's
that
where
at
passive
home.
house starts to become more challenging because you want that breeze. And, but that's usually a controlling of an operable window anyways.
Yeah.
Right.
Yeah. Mm-hmm.
So I would say passive house still makes sense because you're not going to not have the operable window. And I will say, this is where I do get a little grumpy with any of the programs where we start looking at the infiltration rates of what a building is. And the biggest element after we've done the spray foam or the exterior double layer of insulation is the window. Mm-hmm. And the act of how you use the window is important. The best window is the one that's not operable, but that's not practical unless it's like a high up one that you're not going to touch anyways.
Right.
Yeah.
The next best ones are your casement windows, but casement windows are tougher to use. They don't open up all the way. I'm not a huge fan of casement windows because inherently windows will always get left open when it rains, and now that rain is hitting a truck, right?
Yeah.
They start to get beat up over the years.
Yeah.
Double hungs are terrific because you can open them and close them very easily. When it rains, you got your overhangs, your eaves, they're not getting beat up directly by the water unless you have a wind-driven rain, right? Which is going to affect any window. But they're also the least efficient when it comes to infiltration. Mm-hmm. So double hung windows get a big knock, but they're also the nicest use. Mm-hmm. And this is not unsimilar to going back 6-7 years now. The multi-point lock doors were a big thing. Mm-hmm. The problem is when they first came out to use them, you had to know to turn it up to set the multi-point lock.
Yeah.
Most people don't know that.
Don't know how to do
and
that.
so they weren't utilizing it. And actually for some studies, they found that if they weren't in that position, they were actually less sealed than just a good conventional door.
Right. Yeah.
And so the problem is if you don't know how to use it, it didn't do you any good.
Right.
Interesting.
And now they've got a lot better. They've solved a lot of those things. But I think that goes back to when you look at passive house or any program for that matter, sometimes it takes you down a path that just doesn't make sense for the user to use correctly.
Right.
And then what good is it now?
Yeah. Yeah.
Makes
Super
sense.
helpful.
Yeah. Well, so to wrap up, I want to talk about, what are some reasons, which I think we touched on a little bit throughout our discussion, but, to kind of sum up, what are some reasons somebody should consider or they might consider, building to a passive house standard?
Sure. So number one, without a doubt, is going to be longevity of the asset, and looking at how it really should and be helping the environment going forward, which indirectly, in most locations, is going to be saving the client money. Again, you mentioned earlier 30% more. Well, over the duration of it, are they going to see that?
Yeah.
Right. The flipper is not going to see that benefit, right? But the person building a generational home,
Right.
is going to see that. So, those are your initial big drivers. And so we do a lot of passive house. It's a great program. It's got its downfalls like any program does.
Sure.
And the good thing is there's a lot of options out there. You know, one thing that's actually becoming very popular in Texas right now is what the well building program, right?
Yeah.
You never hear of that up north. Very few people actually talk about that.
Interesting.
Because up where I am, up in New England, we're all talking past house. We've brought it into multifamily. They've actually got, like you mentioned before, a commercial program for it.
Yeah.
So that program's got a lot of energy.
Yeah.
Down here in Texas, the well program has a ton of energy.
Totally.
And so depending on the goals of the individual, each program can hit their goals the way they need them to.
Yeah.
And I think the important part is whether it's Pass House or any other program, if you have an owner that's already coming to you without code making to do it, saying, I want to do this, whatever it is, even if they don't hit every point and maybe they don't get the certification, wow, what great progress we already had.
100%.
Right? They're already thinking about it, right?
Yeah.
Think about when we recycle at home. Do we recycle every single thing we do? No. Sometimes I'll admit, I look at my recycling can, it's full. I grabbed that soda can and it went into the garbage. I'll admit it.
100%.
Right? I was like, oh, I'm lazy.
I purposefully buck the system and I put it in the green bin every time. I don't do the blue bin.
If my son does it, I'm going to yell at him.
Yeah.
I'm going to bury the can myself,
yeah.
right? So, but again, the fact is it's there. Every house today has a recycling bin when you pull it out, right?
Yeah.
So that alone is awesome. And so I think what we want to do is no matter what, the principles that are in the overall passive house, helping clients understand them, see the benefits is going to go a long way to building more efficient buildings that are going to last longer.
Sure.
And that's the real win here.
Yeah, absolutely. I think that's
fantastic.
well said.
Yeah.
You got anything else you want to add? Or
No, I think that's really great. And thanks for coming on and talking to us about these different topics.
Yeah, I think that was a good place to end. I think that was very well said, Nick. And again, I'm massively appreciative of you making the trip down here. You know, I'm really thankful that we were able to sit down and connect finally. So thanks for coming on, and we really enjoyed it.
No, thank you. I like the reason. I haven't been in this building in probably 3 years, and I was very excited to have a reason to come back.
Yeah, absolutely.
So thank
Love
you.
it.
Yeah, thanks.